Okay, so this is 9.4, maybe the hardest lesson of this module, but we'll see. Algebraic representations of transformations, objective to be able to describe effects of transformations, including translations, reflections, rotations, and by using algebraic expressions with 80% accuracy given the practice problems. So translation, remember you guys, is a slide. You use a move either up, right, left, or right. So when we are moving right units, so when we're moving the shape to the right, we're looking at the x coordinate. Okay, so that because it's increasing, we're gonna add whatever that number is. So if they tell me to move my shape 3 units to the right, I'm gonna add 3 to the x coordinate. So for instance, if I have 1, 5, and I'm only moving it 3 to the right, I'm gonna add 3 to this one, right? So I'm gonna say 1 plus 3, 5. So then my new order pair is gonna be 4, 5. If I'm only sliding it to the right, and do that to every single one of the x coordinates. Okay. With this one right here, if I move it to the left, because again I'm moving it to the left, that has to do with the x coordinate. I'm subtracting because the numbers are getting smaller to the left side. So again, if I have 1, 3, and I'm moving it to the left 4 places, okay, I'm gonna take my x, I'm gonna subtract 4 from it, and y stays the same. So then that's gonna give me negative 3, 3. That's gonna be my new point if I'm only sliding to the left. And again, you have to do that to each of the x coordinate points. Sure, you add those notes on your whiteboard. I'm not gonna keep it here because I don't have enough space. For this one, if you move it up, that has to do with the y axis. So therefore, I'm gonna add, because the number is going up, it's increasing. So I'm gonna add that to my y coordinate. Okay. So for instance, if I have 3, 5, and they're asking me to move it 2 places up, I'm gonna keep the same, but I'm gonna add 2 to my 5 and end up with 3, 7. Okay, so that will be my new point for my image. Again, pre-image, image, and you're gonna do that to each of the y coordinates. Okay. If I'm moving it down again, it has to do with the y-axis. So I'm gonna take away from the y-axis. So for instance, if I have 3, 7, and they tell me to move down 10 units, I'm gonna go 3, 7 minus 10, and then end up with 3, negative 3. Okay, and you're gonna do it to each of the y coordinates from the points in your shape, in your face. Okay, so that's how we do that. So if they say to describe a transform, let me show you an example real quick. So if they say move a shape 3 units down and let's say 5 units to the right. And so they want you to write that algebraic expression. So you're gonna start with that because that's your pre-image. I'll keep it like that always. And what is it transforming to? Okay, so remember this one has to do with the x-axis because I'm moving right or left, and this one has to do with my y-axis because I'm moving down. Okay, so in this case I have to do my x first. So I'm gonna say, you should write it right here, but I don't have enough. Well, here, I'll erase this. So I'm gonna write x, y, and then it's transforming into what? X, because I'm moving to the right, it's gonna be plus, right? I'm moving to the right, so I'm gonna add. So I'm gonna say x plus 5, y. Now in this case I'm moving down, so if I move down I have to subtract minus 3. And that will be your algebraic expression for a translation that is going down 3 units, 5 units to the right. Okay, let's get to reflections. So remember, reflections are a flip or a mirror image. Okay, and you can, as of now, we're only asked to do it across the x-axis, so it's gonna go this way, or across the y-axis, which is gonna go that way. Okay, so when we do it across the x-axis, I have to multiply each of the y coordinates. So pay attention to that. That's opposite. Okay, coordinates by -1. Okay, so for instance, if I'm giving 1, 3, right, and I'm asking to do a reflection across the x-axis, I'm going to keep my x the same, so that's 1, but I'm gonna make that into a negative, so it's gonna be -3, and that's my order pair. Okay, now if you have something else, another point that is 2, -4. So again, across the x-axis, I'm gonna keep my x the same, but I'm gonna multiply my y times -1, so that makes it opposite, so it's gonna be 4. Okay, so that's if I do it across the x-axis. Okay, now across the y-axis, So across the y-axis, I'm going to do the same thing, but I'm going to do it to the x-coordinate. So if I have 7, 3, okay, and I'm asked to do across the y-axis the reflection, I'm going to change this, multiply by a negative, so that's negative 7, and I'm going to keep the same y-coordinate, okay? So if they ask you to represent a reflection across the x-axis, you're basically just gonna write that, okay? You don't use any numbers like we did. We only use numbers here because that's the specific number of places that you're moving up or down, left or right. And then this one again, if you have to write an algebraic expression to represent a reflection across the y-axis, you're gonna just write that, okay? And I have a little model here. Hopefully that helps you. Okay, same thing right here. Okay, and lastly, rotations. Remember, rotations are turning. Okay, so we're gonna do 90 degrees turn. So we can do 90, 180, 270, and if you do 360, you can end up in the same place. So remember, the 90-degree clockwise rotation is the same as a 270 counterclockwise. Okay, so when we have a 90-degree clockwise or 270 degrees counterclockwise rotation, you're gonna multiply each of the coordinates by -1, and then you're gonna switch them. Okay, but this is only the x-coordinate. Okay, so for instance, if I have 1, 7, okay, so I am going to switch them, right? So 7 is going to go here, but then my x-coordinate, I have to make that a negative, so I have to multiply by -1, so it's going to be this, okay? So that's going to be for this one right here. Now, if I'm given -5, 8 as one of my points, again, I'm going to switch them, so it goes right here, but this one is multiplied by -1, so that's a 5, so it's going to be my new point for my image, okay? Okay, 90-degree counterclockwise or 270 degrees clockwise, same thing. The only thing is that instead of doing it to the x, you're going to do it to the y coordinate. So again, if I have 1, 3, I'm going to switch, so 3, but I multiply that times a negative, so it's -3, 1, okay? And if this was a negative, then it's going to be 3, 1, okay? So again, if they ask you to write an algebraic expression, you're going to just write that with no numbers, okay? And then lastly, 180-degree rotation. Remember when we do an 180-degree rotation from the experimentation that we did in class, you end up in the same place. It doesn't matter if you do it clockwise or counterclockwise, okay? And in this one, there's no switching of the coordinates, but you're going to multiply both of them by -1. So if I have 1, 3, I'm going to end up with -1, -3, okay? If another point is -7, -5, you end up with 7, 5, okay? Alrighty, God bless you. You're amazing. You got this. Don't give up.